Warning: this program is for informational purposes only. It is intended to point out specific engine run-up procedures. You must be qualified to run engines through the process used by your maintenance department. This program does not provide all of the information needed to start and run engines, nor does it supersede any information provided by either the engine manufacturer, Fairchild Aircraft Corporation, or your maintenance department. Of all the maintenance activities a mechanic may be asked to perform, engine run-up is probably the most important. The engines powering the Merlin and Metro aircraft are very expensive and can be easily damaged during run-up operations. This program will show an actual run-up being performed under typical conditions. Fairchild Flightline mechanic Eddie Martinez will be conducting the run-up and will explain the procedure he is following.
Getting out to the airplane, first thing I want to do is check the oil level, ensure we have adequate level. Then I want to check the ramp around the airplane, looking for FOD. Then I want to physically go through each blade looking for nicks and cracks. Afterwards, you want to look in the intake to assure there's no FOD in there. Once in the cockpit, take the control lock off and cycle all your engine controls, checking for ease of operation and smoothness. You're going to make sure your gear selector's in the down position before you put batteries on. Then you want to check circuit breakers, bleed air switches. Make sure they're in the normal position. After putting batteries on, you want to do a pressure test on your annunciator panel. Make sure you have all your lights. Then you do your fire warning system. And look at your engine instruments, make sure they're all in the normal position, and do a pressure test on your gear indicator. You want to check your prop before you rotate. On start, you want to have your one hand on the emergency stop and feather in case anything goes wrong. As you press the start button down, you want to hold the button until you have a rise in EGT, all this time monitoring EGT as the engine accelerates. I guess the two most important things here as the engine accelerates is monitoring EGT and oil pressure. At around 40% RPM, you should start to see a rise in oil pressure. On start, you want to have your power lever, I like to have it forward of the gate to assure you that you're away from reverse and you won't go off the locks, especially if you're going to be doing engine checks where it requires you to be on the locks. After it accelerates, you might want to pull your power lever back a little bit to get away from the higher RPM since your oil temperature is kind of cool. You want to take it down to about 75% RPM. That way you're well away from your reverse range and you'll still be on the locks. You notice your RPM really jumps when you start getting fuel in there on start. At this point, you want to watch your EGT and you'll watch how your automatic function of your computer is holding your EGT temp around 690 plus or minus 5. You can see your EGT pulsate as you get your SPR function of the computer. As your engine accelerates and goes through the secondaries, you'll see a kind of a high rise in EGT up around 720, 730, which is normal, and don't be alarmed at it. At that point, you want to get your bleed airs on, pull out your APU. Once your APU is out, you want to get your generators on the line. You want to select generators. As you put the generator on, you want to look for your voltage increase and an amp rise and make sure you get your generator light and your end panel out. Once your oil temp gets in the green, the first thing I like to do while on the locks is do an overspeed governor check. As you go up in the power levers, you want to be careful because you might have a malfunction of the start locks and it might come off the lock, so be ready for it. Next thing I want to do while on the locks is check your flight idle flats. What I do is take one power lever up at a time, and what I'm looking at is fuel flow, looking for a rise in fuel flow. Then I leave the power levers and check them where they lie. Then I go back to see how the flat straddles the gate. You want to have the same amount forward and after the gate. Same amount of travel. The next check, while still on the locks, is checking your delta P and SRL. What you do is with the power lever set 100% RPM. What you'll do is you'll look at your EGT monitoring the temperature and go to delta P off. You should see a slight rise in EGT of about 5 degrees. Next check is the SRL off. What you do is look for about a 50-degree drop in EGT. Also at this point you want to look at your AN panel. You should get an SRL off light as you select off on the SRL switch. To get off the locks, you go into reverse, monitoring RPM. You should have no more than a 5% split. Next check is checking your overspeed governor high, pushing speed levers forward, monitoring EGT. Underspeed governor high. You want to pull your speed levers back rapidly to assure that you won't have a flame out. Next check is the prop governor low check, which you set 575 EGT with your power levers and monitor the RPM. RPM should be 94 plus or minus a half percent. Also, prop governor low is a good NTS function. Should monitor the RPM with no drooping or lagging in RPM. Our next check is the prop governor high. Push speed lever forward, take power lever up to 575 EGT. We'll be looking at RPM someplace between 99.5 and 101. An ideal RPM is about 100.3. Next check will be prop governor separation. First thing we'll do is put speed levers high. Next we'll set 575 EGT with our power levers. This check will determine if the underspeed governor range of operation is set below the prop governor range of operation. Insufficient separation may interfere with proper better operation. After setting 575 EGT with the power levers, we'll pull the speed levers back to an engine RPM of 96%. Next, we'll pull our power levers back and find a minimum fuel flow. At this point, engine RPM must stabilize at 93.5% or less. we should have no more than a 2.5% RPM separation. Next thing we want to look at is our beta switch operation. At this point, we should have a beta light. If not, we can advance our speed levers up to 85%. We should have a beta light before 85%. Now what we want to do is look at our power. What we'll do is we'll set our altimeter for field barometric, and we want to look and see what our outside air temperature is. Using our chart, we'll look and see what the torque for the day will be. At this point, you want to make sure you have chocks, as on cold days you'll be pulling a lot of torque and there's a possibility of jumping the chocks. What you'll want to do is advance the power lever slowly, and as you accelerate, you want to monitor all engine instruments to assure that everything is accelerating normally. As you advance, it's a good idea as you go through the different EGT temps to look at your different governors once again. As you advance the power levers, you want to monitor your torque and all engine instruments to see how they accelerate. Today's torque is about 79%. Once you achieve that torque, you want to monitor your EGT, fuel flow, and RPM. Okay, our next check is going to be a temp limiter check, or in effect what we're looking at is our fuel bypass valves. What we'll do is push speed levers forward and set 350 fuel flow with our power levers. What we'll be doing is monitoring your bypass light and the amount of fuel bypassed by the valve itself. So what you do is you'll select temp limit check on the left, and you'll watch your bypass light come on, and you should drop approximately 90 pounds of fuel. Our next check is going to be our cruise power setting. What we'll do is take speed levers up and push our power levers up to around 500 EGT, then pull our speed levers back to cruise RPM, which is 97. At this point, I'm going to take the power levers up all the way up to 650 and above to see what our temp limiter is limiting fuel at. If you remember, we just did that check and we saw that it worked and it dumped fuel when we got light. So what I'll now do is take the power levers up to around 650 and see at what temperature our temp limiter is going to dump fuel. A good temperature for our temp limiter to be set is about 652. After I see that the bypass is working on both sides, I like to pull my power levers back to about 640. And what I'll be doing is looking for power lever splits and speed lever splits. I'll set my speed levers at exactly 97% on both engines and set my power levers right at 640. This is a good time to check your rigging to see how your left and right engines are tracked compared to each other. At that point, you look at your engine instruments and you'll see that all indications are pretty well matched up. Your power levers are tracking right and your speed levers are right. Now is a good time to look at our prop sync. What I'll do is turn on the prop sync and see if our RPMs are holding. A good way to check this now is to turn it off and create a split by moving one of the speed levers. You want to get it slightly out of sync of about 0.5%. Now I'll turn the prop sync back on, and the sync should drive the RPM up and they should match once again. Next check will be our CAWI system. What I'll do is I'll look up the torque, and I see that for today we're at max allowable, which is 110% for the temperature. Once again, we'll be pulling a lot of torque, so you want to make sure that the area in front of you and in back of you is clear and you have some chalk set. What I'm doing is checking the test switch to make sure that our pumps are primed and we have a light corresponding to each engine. Now what I'll do is I'll put speed levers high and move the power levers and set about 30% torque, and I'll fire the AWI to make sure that I get a torque rise and the bleed arrow shuts off. So we have lights and everything appears to be normal. For safety's sake, I'll take one engine up at a time to avoid jumping the chocks. Once again, as I advance the power levers forward slowly, I want to monitor all engine instruments for normal acceleration. At this point, you really want to watch your torque indicator because you don't want to exceed book torque, which was, as we said, 110%. Okay, our next check will be an engine out. What I'll do is pull the temp limited circuit breaker on the left side. At that point, we should have a light go out and we'll see that no water is firing on the left side to assure that if we actually have a dead engine, we won't be firing water in that engine. Our next check will be our 90% switch. As I pull the speed levers past 90%, we'll watch that our corresponding pump will go out for that engine. That completes our AWI check. Now our final check will be reverse high. What I'll do is put the speed levers forward, go sharply into reverse, looking for a torque split. Max allowable is 4%. I'll release the power levers, and you want to ensure that the power levers go someplace close to ground idle to assure that we're out of reverse blade angle. That completes our engine check, what we'll do now is wait for a minimum of 3 minutes for adequate cool down. During the 3-minute cool down, observe all engine instruments looking for obvious signs that neither engine is still in reverse. The instruments will verify that both engines are set at a true ground idle. After 3 minutes, we'll turn our bleed air off and generators and all accessories. We'll press the stop buttons and we'll note a rise in RPM, which tells us that our EPA fired. At approximately 55%, we'll go hard into reverse to assure that our props get on the start locks, and we'll hold it to about less than 10%. After 10%, we'll cycle our controls and set our gust lock.